go, 5.4. We're going to graph using slope-intercept form. That song you probably don't recognize yet. It comes from the best math game you've probably ever played today. It's an amazing game that after this section you can go play and have some fun with. Very good. Also, Mr. Sullivan really loves that sound. He loves the sound quality of that song. So if you want to rewind that, unplug the headphones, blast it as loud as you can in Mr. Sullivan's room. Shoot, give it to Mr. Kelly. Everybody appreciates a good tune like that. And excellent. So let's get it rolling. What are we doing here? We're doing 5.4. This is huge. This section is huge. This is like a defining moment in algebra. We have to be able to do this. We're going to do it the rest of the year. I'm not even overhyping this. It's slope-intercept form. It's y equals mx plus b. So if you got through slope, you're ready for this. That's why we spent so much time on slope, hammering it out. What is slope? So it's called slope-intercept form. There's two things why this form is nice. It's y equals mx plus b. We know from last section that m stands for slope. So this is the slope of the line. Y equals mx plus b. Boom, m is the slope. What do you think of with slope? Here's what I want you to think of. You got to think of rate of change. Slope and rate of change, interchangeable. I can call them either one. Also, rise over run, and when I think rise over run, I think about y's over x's. That's huge. I'm always putting my y's over my x's. Rise sounds like y's. This delta here, this little triangle means change. This is the change in y over the change in x, and we wrote that as this fancy little formula. Subtract your y's over subtract your x's. So those are things we got to know about slope. It's part of this formula that we're going to keep using for a long time. So hopefully we're good with that. Y-intercept, then, if you can guess, is now we're going to call it b. That is the b. So I didn't make this up. It's not m and b for like Mr. Bruss. This is the real deal. This is it. B is the y-intercept. What do you think of when you think y-intercept? Hopefully you're thinking something about the starting point or the initial value. Did you start with 5 cakes and you make 3 cakes every 4 hours? Something like, what did you start with? Obviously an intercept, back to the section before that, is a point where it crosses the y-axis, so that's the formal definition, and we see that with 0, y, the actual coordinates. So those are important. This is huge. We're talking about y equals mx plus b, so make sure you have this written down, have it. X and y are always changing. They're going to change, whatever x is changes y. That was that whole independent, dependent kind of thing we looked at. So it's changing. So they're going to stay variables. So what we're going to do is graph using this formula. What's nice about this, I can instantly see the slope. I can instantly see the y-intercept. In this case, I can't find the x-intercept without a little bit of work. So it's a little bit of a drawback. But overall, it's the one we prefer to. Alright, so let's start using this formula to graph some of these things. So over here I wrote the formula, so we always have it, y equals mx plus b. If you want to put it above, let's take a look at our first one. Our first one is y equals 2x minus 4. So if you think of mx plus b, let's find what we know here. We know the slope is what? M is what? It is 2. The slope of this line is 2. So what is b? B in this case is negative 4. So what we can do here is, let's start graphing it. Where do I start at? I start at negative 4. So he started negative $4. What are you doing from there? Well, you're doing your slope. Remember, everything's a fraction. The number from x is the slope. Even if it's just 2, it's really 2 over 1. 2 divided by 1 is 2. So everything's a fraction. So my slope is rise 2 over 1. From your initial point, I start at negative 4, boom, up 2 over 1. Then up 2 over 1, up 2 over 1, up 2 over 1. So I want you to fill up the whole graph with dots. Then once you have your dots, get a nice straight edge, draw it straight through there. Ooh, start off rough, but not too bad of a line. So I see all the dots in there, fill up the graph paper. That is the equation of the line. So I can tell it started at negative 4, has a slope of up 2 over 1. Fantastic. How about this one over here? Where does this guy start? He starts at plus 4, so let's say you have $4 in this case. Then what's happening? Well, it's negative 5/4, and the negative really messes with some people. If it's negative 5/4, the way I like to think about it, that's the same thing as, go ahead and put that negative on top. I always think of my rise as the negative. It's legit. It's the same thing, negative front or negative on top. You could actually put the negative on bottom, but I like to think of on top. Why? Because what am I rising? I'm rising negative 5. So to rise negative 5, you're actually going down 1, 2, 3, 4, 5, then over 1, 2, 3, 4. There's my second dot. That's all that'll fit. And then from there I can draw a straight line. Hope yours is straighter than mine. Like that. So what's cool about this, if I look at the slope of this, the slope of this line is positive. This line is positive. If left to right, it's going uphill. This slope was negative, and it's going downhill. It's a negative line. So double check your slope. If your slope's negative, your line better go downhill. It's the most common mistake. That'll keep you from doing corrective assignments and all that fun stuff. Excellent. How about the next one? X, whoa, this does not fit my y equals mx plus b. Special case, it says x is 4. It just means x is always 4. So find x, here's the x-axis, x is 4. There is no y-intercept, so it's that special case, here it is. It's straight line up, straight line down. It means x is always 4. So we may run into vertical lines. It has that undefined slope. That can happen. Don't freak out. Alright, let's go down to the bottom here. I'm going to change colors. How about this one? Where does it start? Well, mx plus b. I forgot the x on this. I'm going to write it in here. I hope it should be on your notes there. Sorry. Negative 1/4 x plus 3. It starts up here at 3. And what am I going to do? I'm going to rise down. Remember, I say negative 1/4. And I'm going to go down 1 over 1, 2, 3, 4. Can I continue the opposite direction? Sure. Instead of going down 1 over 4, I could go up 1, back 1, 2, 3, 4. So same difference here. And I'm going to slide that and get a nice line like that. So try to fill up all the graph paper with dots. Very nice. How about the next one? Sometimes people freak out about this one. Don't freak out. What is b? Do I see b? Aha, there is no b. So what does that mean? B is 0. I can still see my slope is 1/4, the number in front of x. B is 0. If it really helps you, you could do this. Say 1/4 x plus 0. But you're starting here at 0. You have no money. You have nothing. What are you doing? You're getting up 1 over 4. Put a dot. And fill it in the other way. Instead of going up 1 over 4, you can go down 1 back 4 and put a dot. And boom, there it is. Woo! Love it. So is it a positive slope? Sure, it's a positive slope, positive line. Again, negative slope, it's going downhill. Negative slope, negative line. And the last one, this one's kind of tricky, so I kind of picked the bottom row, some tricky ones here. It's 3 minus x. If there's nothing written in front of x, how many x is that? Well, it's just 1x. So don't freak out. There it is, 1x. So where am I going to start in this thing? I'm going to start at b, which is 3. And then my slope is negative 1. But remember, it's a fraction. It's negative 1 over 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And can I go back? Sure. Up and then back, up and back. Keep that pattern going. Straight line through there. And good. I've got a negative slope, negative line, so I am good to go on that. Fantastic. Let's keep this rolling. Alright, here we go. So can we write the equation of the line? So what if I give you a graph and I say, okay, what's the equation line? So this is a great skill to have. So think about something like this. I know the equation. We're going to write m y equals mx plus b. So anytime you do this, you're looking for two things. You're looking for m and b. If you can find m and b, you're in business. You're good to go. So let's start with b. I think that's a nicer one to find. B is the y-intercept. So what's the y-intercept of this line? Boom, right here. Negative 1. So its starting point is negative 1. You have negative $1. Then what's it doing from there? So what's the slope of this line doing? Well, from here, it looks like it's going down 1. Where's it hit up perfectly? Aha, over here 3. So if there are no dots, you got to kind of put your next dot in where it crosses the grid perfectly. So does it keep going down 1 over 3? Sure. How about the other way? Up 1, back 3, up 1, back 3, and it keeps that pattern going. So you can tell here it's down 1 over 3, so negative 1 over 3. So my slope is negative 1 over 3. So I found the slope, I found the y-intercept, so can I write the equation? Sure, it is y equals negative 1/3 x, there's my slope, plus b, which you can put plus negative 1 or just minus 1 if you want. That's the equation of the line right there. Love it. Alright, let's take a look at the next two examples. Special cases. We got some special cases here. So this case is what's going on here. What is the first? Let's just do our m and b. Where's its y-intercept? There it is, right there. I can see it right there. It's at 1, 2, 3, 4, 5. So this y-intercept's at 5. What's the slope of this line? It's rising how much? It rises nothing. There is no rise in this line. What's its run? Well, every time it goes over like 1, you could say 2 or 3. Doesn't matter. What's 0 divided by any number? It's 0. So you can write this as y equals mx plus b, 0x plus 5, or really 0 times anything is 0. You can just say y equals 5. So this is special case y is always 5. You get that horizontal line there. Fantastic. How about this case? Another special case. If I look at this, where is its y-intercept? Where does it cross the y-axis? There's none. Ooh, bummer. So it's not going to fit in my normal y equals mx plus b mode. Does it have a slope? I mean, really, it's rising every time, isn't it? You could say it's going up 1 or 2 or whatever number you really want. But it's running how much? How much does it go horizontally? None. Well, can you divide anything by 0? No, that's impossible. it's undefined. So this is a weird one that has an undefined slope, no y-intercept. So all we can really do is say x equals what? 1, 2, 3, 4. That's -4. Fantastic. I threw a little shout out here for Algebra versus the Cockroach. This game is awesome. That's what it's all about, is writing equation in line. As you do it, you kill cockroaches. You can choose your weapon. It's a lot of fun. I put a link on the website. Go play it. Hey, I just learned this great trick for those special cases like the one above here called HOI. Check this out. So when you have a special case like that, the H is for horizontal. It's a horizontal line like the horizon. So you got a horizontal line. The O is for a zero slope. So zero slope. And then the Y is for it's a Y equals. So just like the one above is Y equals 5. This will help you remember horizontal zero slope y equals HOI. Alright, what about for vertical lines? Well, we have VUX. VUX means we've got this vertical line straight up and down, and that has a what? It has an undefined slope. So it has an undefined slope when it's going straight up and down. And what is that? That is an x equals kind of problem, just like the one above is x equals -4. So when you see x, you know it has an undefined slope and it's a vertical line, versus HOI, horizontal zero slope, y-intercept, or I'm sorry, y equals. Great way to remember these special cases so you get these right. Awesome, moving on.
We got 2 more slides though real quick that we're going to hammer out here. Let's check them out. What if it's not in slope-intercept form? So if I look at this, it's not in standard form, it's not in slope-intercept form. What am I going to do? Luckily, we spent part of Chapter 3 solving for y. This is why we were doing it. Solve for y is hugely important. Something we got to be able to do. So I'm going to solve for y. So to get y by itself, what do I got to do in this case? I like to draw this line down here. I'm going to divide both sides by 2. So the 2's cancel. I'm left with y equals 6x minus 8 divided by 2. And I can split this up as 6x divided by 2 minus 8 divided by 2. And can I simplify that a little bit? Sure, 6 divided by 2 is 3, so I have 3x. 8 divided by 2 is 4, so I have this. Now I am in slope-intercept form. So really slope-intercept form means solve for y, then graph it. I know it crosses my y-intercept -4. The slope of this line is 3, but it's like 3 over 1. So I'm going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1, 1, 2, 3 over 1. Fill that bad boy up with dots. Boom, there they are, points on my line. I'm good to go. Excellent. Oh, how about this one? This one's even worse. It's not solved for y, so I got to solve this thing for y. Again, so I don't get confused, I like to draw a line down here on the equal sign just to keep my thoughts straight. I want to get y by itself, so I got to get rid of this 4x. So to get rid of the 4x, I got to subtract 4x from both sides. So these cancel out. I'm left with, this is the key, this is a -3x. Do not forget that negative sign. I'm sorry, 3y. Do not forget the -3y. Can't combine these are not like terms, so all I can do is say it's 9 minus 4x. Then what am I going to do to get y by itself? Well, it's -3 times y, so I'll do the opposite. Divide by -3, divide by -3. These cancel. I'm looking at y equals 9 divided by -3 minus 4x divided by -3. And really I need to simplify this a little bit more. What is 9 divided by -3? Well, it's -3. What's a -4 divided by -3? This becomes positive. I got my double negative there, and I'm going to leave it as a fraction. It stays positive 4/3 x. So this is the equation of the line I need to graph here. Fantastic. So looking at it, remember the number without the x is the y-intercept. So I'm going to start here, my y-intercept at -3. And from the y-intercept, I'm going to go up 4. 1, 2, 3, 4 over 1, 2, 3. Put a dot. I think that's the only one that fits. There's my line. I always double check. Yes, I have a positive slope. This is positive. I'm good to go. Alright, here we go. So real quick, this is a good time to pause, play the game. Here, I'm just going to, you watch me play a little bit if you want. I play this pretty much all the time on the weekends and whatnot. I'm going to pick a shoe to kill the cockroaches with. Also, there's an application problem that you can, that you can do and check it out. I put a video at the bottom. It's good if you're having a hard time with these applications. I thought it would be here's cockroach. Down here you type, pause it. Down here you type in the equation. So here's the cockroach. He's doing the line. He's going straight back and forth. And you got to hurry. They're multiplying. If there's too many, they get you. So this equation I know has no slope. It's just y equals -2. I'm going to type it in, and I'm going to hit fire. Here comes the shoe, and it stomps them out. Excellent. So I won round 1. I'm going to play for a little bit. Peace out. Keep it real.